Hello dear students, welcome to physics class of P1. In the previous video class, we have given the introduction about mechanical properties of fluids. So in this topic already we have discussed what is a fluid, what is a fluid pressure, what is density and the variation of pressure with depth. And also we have discussed what is a Gauss pressure and what is hydrostatic paradox. Now in this class let us going to study about one of the important law in fluids, mechanical properties of fluids, that is Pascal's law. Since you all know that liquids and gases play an important role in our life, the earth's atmosphere is a big ocean of gases. About 75% of the surface of the earth is covered with water. So we cannot think of a life without gases, that is air and water. Liquids and gases are collectively called as fluids, and fluid is a substance that flows under the action of an applied force and does not have a shape of its own. So all these points we have covered in the previous class, and also we have discussed the two branches of fluid mechanics. One is hydrostatic or fluid statics, and another one is what, the hydrodynamics. The study of fluids at rest is known as hydrostatic or fluid statics, and the study of fluids in motion is known as hydrodynamics. Now the next point of this syllabus is we are going to discuss about the Pascal's law. What is Pascal's law and what are the important applications of Pascal's law? Pascal's law. According to the Pascal's law, the pressure applied to an enclosed liquid is transmitted to every portion of the liquid and walls of the container undiminished in magnitude. Right? In an enclosed fluid, the change in pressure at any part of the fluid is transmitted to all the parts of the fluid and walls of the container without diminished in magnitude. That means whatever the pressure you are going to apply, that is transmitted to every part or every portion of the liquid without diminished in magnitude. For example, every time you squeeze a tube of toothpaste, you demonstrate the Pascal's law here. The pressure that your fingers exert at the bottom of the tube is transmitted through the paste and forces the paste to out at the top. So this is because of the Pascal's law, what we are giving the example here, right? Whatever the pressure applied to an enclosed fluid, right? Whatever the pressure applied to an enclosed fluid, that is transmitted to every portion of the liquid here, that right, that is transmitted to every portion of the liquid and also the walls of the container without diminished in magnitude. So this states what here the Pascal's. Demonstration of Pascal's law. Consider here a vessel containing a water and fitted with four frictionless pistons A, B, C and D. So here we have four frictionless pistons A, B, C and D. These are the four frictionless pistons, and in a vessel, the vessel is containing a water, and the cross sectional area of the four pistons are A1, A2, A3 and A4 respectively. Now, when a pressure F1 is applied on the piston to move it, right, and hence the pressure exerted by the piston on the liquid is equal to what? F1 is A is equal to F1 divided by A1. So this is what the pressure on the liquid exerted by the piston A. Now, according to Pascal's law, that pressure is transmitted equally in all the directions, right, without diminished in magnitude. It is transmitted to every portion of the liquid and walls of the container without diminished in magnitude. And it is found that the pistons B, C and D can be held in their respective position if we apply the forces F2, F3 and F4 such that F2 by A2 is equal to F2 by A3 is equal to F4 by A4 is equal to F1 by A1. That means what? All the pressures exerted by the piston on the liquid is equal, then the pistons will be held there at respective position. That is P1 is equal to P2 is equal to P3 is equal to P4. That means what? That when you apply the pressure on the liquid by the piston, that pressure is transmitted equally in all the directions, all the parts of the liquid and also the walls of the container without diminished in magnitude. So this law is known as what? The Pascal's law.
Demonstration of Pascal's law. Pascal's law states that when pressure is applied at a point in a confined fluid, it is transmitted equally in all directions. Let us perform an activity to understand Pascal's law. Shown on your screen is a vessel having a number of openings. These openings are furnished with projecting tubes of section area A, B, C, D. These projecting tubes are fitted with airtight pistons P, Q, R, S, which are capable of sliding into the projecting tubes. Fill the vessel completely with a liquid. The only forces acting on the liquid are the forces applied on the pistons P, Q, R, and S. Now push the piston P down into the liquid. What do you observe? We observe that the other pistons Q, R, S are moving outward. Why is it so? This is because the pressure exerted on the piston P is transmitted equally in all the directions in the liquid, thus moving the other pistons. This proves Pascal's law.
Now the important applications of Pascal's law, that is hydraulic machines. The devices which work on the Pascal's law are known as hydraulic machines. So the important applications of Pascal's law are hydraulic lift, hydraulic jerks, hydraulic brakes and hydraulic pumps. So these are all called as what? The hydraulic machines which work on the uh, principle of Pascal's law, and also the dentist's chair which also work on the Pascal's law. Now in our syllabus we are going to discuss here the two important applications. One is hydraulic lift and another one is hydraulic brakes. So these two applications we are going to discuss here. The first one, hydraulic lift. So what is hydraulic lift? Its construction and working we have to discuss here. The hydraulic lift consists of a horizontal fluid filled container. So here we have the horizontal fluid filled container. The hydraulic lift consists of what? The horizontal fluid filled container. So this is a fluid filled container, and both the ends of the container are fitted with two cylinders C1 and C2. So here we have the two cylinders C1 and C2, right? Now and these two cylinders are fitted with a pistons of different cross-sectional area A1 and A2 as shown in the figure here. A small piston of cross-sectional area A1 is used to exert a force F1 directly on the liquid. So here this is a small piston of a cross-sectional area A1 which exerts a force F1 directly on the liquid, right? A small piston of cross sectional area A1 which exerts a force F1 on the liquid. Therefore the pressure exerted on the liquid is given by P is equal to F1 divided by A1. So P is equal to F1 divided by A1. It is the force exerted. P is equal to F1 divided by A1. It is the pressure exerted by the piston on the liquid directly. Now according to the Pascal's law, this pressure is transmitted throughout the liquid to the large piston. So what happens here? Whatever the pressure exerted by the piston, small piston, this is transmitted to the large piston. That is a big piston. Now that pressure is transmitted throughout the part of the liquid without diminution in the magnitude according to the Pascal law. Therefore, the force on the larger piston is given by F2 is equal to P into A2, because pressure is equal to what? Force divided by area. Therefore force is equal to pressure into area. Therefore again what happens here, the pressure exerted by the piston, small piston, it is transmitted to what? The large piston without diminution in magnitude. Therefore F2 is equal to P into A2, but P is equal to what? F1 divided by A1. From the equation we can put here, therefore F2 is equal to what? A2 divided by A1 into F1. Therefore the force on the larger piston is given by F2 is equal to A2 divided by A1 into F1. So since A2 is greater than A1, the cross sectional area of large piston is greater than the small piston. Therefore the force at the large piston is increased by the factor A2 divided by A1. So F2 is equal to A2 divided by A1 into F1. So we are getting here F2 is greater than F1. It means what? The force on the larger piston will be much more than the force applied on the small piston. So this can be used to lift the heavy load placed on the platform of a large piston. Therefore, the heavy loads like cars and trucks can be lifted by the application of small forces. That is the application of Pascal's law, that is called as the hydraulic lift. Now let us discuss here the next application of the Pascal's law, that is the hydraulic brakes. So what is a hydraulic brake? Hydraulic brake is a system which is used in automobiles to retard its motion. That is called as what? The hydraulic brakes. So what is a hydraulic brake? It is used in automobiles to retard its motion, right? To retard its motion, these hydraulic brakes are used. Now let us discuss here its construction and working. The construction of hydraulic brake system. The hydraulic brake system consists of a master cylinder fitted with a piston. So here we have this is called as the master cylinder. This master cylinder fitted with a piston P. This is fitted with a piston P, and this piston P is attached to the brake pedal with the help of lever system. So this piston P is connected to the brake pedal with the help of a lever system. Right now what we have discussed here, the hydraulic brake system consists of a master cylinder which is fitted with a piston P, and that piston P is attached to the brake pedal with the help of a lever system. So this is the first point. Now the master cylinder is connected to a wheel cylinder through the tube. So the master cylinder is connected to uh, this master cylinder is connected to the wheel cylinder through a tube. So we have the tube here. Through this tube the master cylinder is connected to the wheel cylinder. Then again wheel cylinder consists of two pistons P1 and P2. So this is a wheel. Now This wheel consists of two pistons P1 and P2, right? The master cylinder is connected to the wheel cylinder through a tube, and wheel cylinder consists of two pistons P1 and P2, right? These pistons press against the brake shoes S1 and S2. So these S1 and S2 are called as brake shoes. S1 and S2 are called as what? The brake shoes S1 and S2, and the piston press against the brake shoes S1 and S2. Now let us see here how this is the construction of the hydraulic brake system. Now let us see here how this hydraulic brake system works. Now the working of hydraulic brake system. When the brake pedal is pressed with a foot, the lever system works. The piston is pushed into the cylinder. So when the brake pedal is pressed here, when the brake pedal is pressed with a foot, the lever system works. The piston P is pushed into the master cylinder. So here the piston P is pushed into the master cylinder. The pressure so produced is transmitted equally to piston P1 and P2 of the wheel cylinder. So whatever the pressure produced by the master cylinder, that is equally transmitted to the pistons P1 and P2 of the wheel of the cylinder. So due to this pressure, the piston P1 and P2 move outward. So here, due to the pressure given by the master cylinder, the pistons P1 and P2 moved outward, and hence the forces the brake shoes to expand outwardly. These brake shoes press against the inner rim of the wheel and retard the motion of the wheel. And also this master cylinder is connected to all the wheels of the vehicle in order to apply equal pressure to all the wheels. So in this way the hydraulic brake system works, and the Pascal's law helps in what to retard the motion of the vehicles, that is automobiles. So this is the very important application of the Pascal's law. One is the hydraulic lift and another one is the hydraulic brakes. So these two for our syllabus we have discussed here. The first one is hydraulic lift and another one is the hydraulic brake. Now let us solve here one numerical based on the hydraulic lift. A car of mass 3000 kg is to be lifted by a hydraulic lift as shown in the figure here. The area of cross section of the piston carrying a car is 50 centimeter square. So the area of cross section of the piston carrying a car is 50 centimeter square, and the area of cross section of the small piston is 10 centimeter square. Calculate the force needed to be applied on the smaller piston to lift the car. So according to our Pascal's law, F1 divided by A is equal to F2 divided by A, or F1 divided by A1 is equal to F2 divided by A2, where A1 is the area of small piston and A2 is the area of larger piston. So here we have denoted small a is the area of a smaller piston and capital letter A is the area of larger piston. So area of smaller piston is 10 centimeter square, that is converted into SI unit, that is 10 into 10 to the power minus 4 meter square, and that is equal to 10 to the power minus 3 meter square. So plus 1 minus 4 is minus 3 we have written. Then similarly the area of larger piston is equal to 50 centimeter square, that is equal to 5 into 10 to the power minus 3 meter square. So that is equal to what? 50 into 10 to the power 50 into 10 to the power minus 4 meter square. So that is it written in terms of, again by changing the digits here, that is 5 into 10 to the power minus 3 meter square. Now the weight of the car, that is force needed to apply the force at the second piston, that is F2, is equal to what? The weight of the car, and that is equal to mg. So m is the mass of the car and g is acceleration due to gravity. So the weight of the car, that is F2, is equal to 3000 into 9.8, that is equal to 29,400 Newton. Now what is the pressure applied on the smaller piston to lift the car, that you have to calculate here. Then according to the Pascal's law, F1 divided by A is equal to F2 divided by A, that is pressure applied at the smaller piston that is transmitted to the what, the larger piston that is equal in magnitude. So P at smaller piston is equal to P at larger piston. Therefore F1 divided by A is equal to F2 divided by A. So F1 is equal to F1 we want to calculate here. Therefore F1 is equal to F2 into A divided by A. Small letter A is the area of a smaller piston, and capital letter A is the area of larger piston. So by substituting the values here, F1 is equal to 29,000, F1 is equal to 29,400, it is the force at the second piston. So F2, and then small a is 10 to the power minus 3, and large capital letter A, that is the area of larger piston, 5 into 10 to the power minus 3. So 10 to the power minus 3 and get cancelled here in the numerator and denominator, and 29,400 divided by 5 is equal to 5,880 Newton. This force is needed to be applied on the smaller piston to lift the car. So this is the simple example what we have solved here, that is based on the what, the Pascal application of Pascal's law, that is the hydraulic lift. So simple law, it is what, P is equal to the pressure applied at the smaller piston that is equally transmitted to the what, the larger piston. So P at small piston is equal to P at large piston, that is equal to F1 divided by small a is equal to F2 divided by capital letter A. So also you can write it as a what, F1 divided by A1 is equal to F2 divided by A2, um, that is the pressure applied at the smaller piston is equally transmitted to the larger piston. So this is what the application of Pascal's law, hydraulic lift.